Hello students, welcome back. So in this next section, we'll be looking at pyramid. So what exactly is a pyramid? So in mathematics, how we understand pyramid is a solid in which one of the faces is a polygonal, right? Polygonal base, right? And the other lateral faces, okay, are triangles joined to the edge of the base. Okay, so the corners of the pyramid, okay, they are known as vertices. And the vertex where all the slanted faces, right, the lateral faces, okay, they meet is called the apex. Okay, so this is what we have, right? Oh, sorry, let me undo this. Instead of lateral, I think we use the word slanted in this case because they are slanted towards the apex. I think that makes a better clarity for you, right? Better word to use. So that's basically some idea. You have some diagram to show you how they look like. So you can see here pyramids. I mean the one that we are familiar with is maybe a square base, but it can be any polygonal base, right? So in this case, you even have a rectangular base here, rectangular, and in this case even hexagonal, right? Hexagonal. So as long as it's a polygon as a base, it works. Okay. So again, just like when we're talking about prism, pyramid not necessarily has to be a right pyramid, but for the purpose of our syllabus, we will focus on right pyramid. Right pyramid simply means that the apex is actually above the center of the base, right? So it's not like slanted to a side or something like that. So this is how a right pyramid look like. You can see that the apex, when you draw a line down to the base, the center of the base, it forms a perpendicular 90 degrees. Okay. So how about the calculations and the formulas? Well, the volume of a pyramid, right? If we compare it to, let's use a square pyramid as to visualize, right? If you compare it to the cuboid of the same height, okay, is actually 1/3, right? So we can actually prove it in a various number of ways, but we can do that offline, right? So that I can finish this first. We get the basic understanding first, and then we can figure out the proof later for those who are interested. Okay, so it's 1/3, right? So in this case, okay, the volume of corresponding prism. So since we already know what is the volume of the prism is the base area times height, right? Therefore, a pyramid, the volume is 1/3 base area times height, right? Now, how about the total surface area? Total surface area, what happened is when we look at the net of the pyramid, you will find that the base is there right in the center, but surrounding the base, right, you will actually see triangles. Okay, so it is the area of all the triangles, and then you add them to the base, right? So that's how it works. So those triangles, they are lateral faces or slanted faces. Different names, but they mean the same thing in this case, right? So the geometrical pyramid, right, we can see is a model for many architecture, contemporary civilization and so on, right? Many things is based on the pyramid, right? So we will leave this discussion in person if necessary. Let's move on. So here's a standard question, right? The height of the Great Pyramid of Egypt, a very famous one, is huge, right? So what it is it has a square base, and the square base is 229 and meters in length, and the height is 146. It's a right pyramid, right? So to find the volume, let's apply the formula, right? The volume is 1/3, and the base, since it's a square, is 229 square, right? So that will be the area of the square times the height, 146, right? So you work this one out, is 2552128.66, etc. Okay, so of course we want three significant figures. So in three significant figures, it will be 255,000 cubic meters. So that will be the volume of the pyramid. So it's a huge structure, right? Okay, part B, we have a much smaller pyramid. Don't worry, right? Now it has a square base of 12. Sure, we are told that the slant height is 15. Draw its net and hence find the total surface area. So how does the net look like? We have a square, right? and we have the triangles at the side, right? So pardon my drawing. If you use a ruler on your paper, it'll probably look nicer than what I'm doing here with freehand. But I mean, I'm drawing on the screen, so not the best one, right? But anyway, okay, we have 12 meters here, right? And this length over here is actually 15 meters. Okay, so from here we can find the total surface area. Total surface area is equals to, well, we have 12 square for the base in the center, plus there are 4 of these triangles, so 4 of them. Each triangle is half times base times height, right? So you work this one out, it will be 504 square meters. All good? Let's see. Right, so that ends the section on pyramid. In the next video, we will talk about the cone, right? The cone.